Science and Engineering Department as an assistant professor in Walchand Institute of Technology, Solapur. Today we are going to discuss the topic of software engineering, that is data flow diagram. At the end of this session, student will be able to describe the different data flow diagrams used in software engineering. Data flow diagram. Actually, it is defined as DFD is the abbreviation for data flow diagram. The flow of data of a system or a process repeated by DFD. It also gives this insight into the inputs and outputs of each entity and the process itself. It is a graphical tool useful for communicating with users, managers, and other personnel. It is useful for analyzing existing as well as the proposed system. So, data flow diagram provides an overview of what data system processes, what transformation are performed, what data are stored, what results are produced, etc. Data flow diagram can be represented in several ways. DFD belongs to the structured analysis modeling tools. The characteristics of DFD. So, DFDs are commonly used during the problem analysis. DFDs are quite general and are limited to problem analysis for software required specification. DFDs are very useful in understanding a system and can be effectively used during the analysis. It views the system as a function and transforms the inputs into desired outputs. The DFD aims to capture the transmission that takes place within a system to the input so that eventually the output data is produced. Components of DFD are process. Input to output transformation system takes place because of process function. The symbol of process are rectangular and rounded corners, oval, rectangle or circle. The process named a short sentence in one word or phrase to express its essence. Data flow. Data flow describes the information transferring between two parts of the system. The arrow symbol is the symbol of data flow. A reliable name should be given to the data flow to determine if the information which is being moved. Warehouse. The data is stored in warehouse for late use. Two horizontal lines represent the symbol of the store. The warehouse is simply not restricted being the data file, rather than it can be anything like a folder with documents, an optic disk, a filing cabinet. Next component, terminator. The terminator is external entity that stands for outside the system and communicate with system. It can be, for example, organization like banks, groups of people like customer or department, different departments of the same organization, which is not part of model system, is an external entity. So this is the diagram of the component data flow diagram, where data warehouse is shown. Input is given from the warehouse, giving it to processing unit, and output is given to the user. So this red arrow signify the flow of the data. The arrow indicates the data. So basic structure of this is the basic structure of DFD. Symbols used in DFD: square box. A square box defines the source or destination of the system. It also called entity. It represented by rectangle. Arrow or line. An arrow identifies the data flow. It gives the information to that is in motion. Circle or bubble. It represents a process to give us information. It also called processing box. Open rectangle. An open rectangle is the data store. In this data store either temporarily or permanently. Rules for creating DFD. The name of the entity should be easy and understandable without any extra assistance. The process should be numbered or put in ordered list to be referred easily. The DFD should maintain consistency across all the DFD levels. A single DFD can have a maximum of 9 processes and a minimum of 3 processes. Levels of DFD. DFD uses a hierarchy to maintain transparency that those multiple level DFD can be created. Levels of DFD as follows. 0 level DFD. It represents the entire system as single bubble and provides the overall structure of system. Level 1 DFD. This represents main function of the system and how they interact with each other. Second level of DFD. It represents the processes within each function of the system and how they interact with each other. Third level DFD. It represents the data flow with each process, how the data can be processed and stored. Advantages of DFD: easy to understand. So So DFD is graphical representation that are easy to understand and communicate with the useful and for non-technical stakeholders and team member. Improve system analysis. DFDs are useful for analyzing system processes and data flow, which can help identify insufficiencies, redundancies, and other problems that may exist in the system. Suppose system design. So it will be supporting system design. So DFDs can be used to design a system architecture and structure, which can help ensure that system design to meet the requirements of the stakeholders. Disadvantages of DFD can be time consuming. So creating DFD can be time consuming process, especially for complex system. Limited focus. DFD focus primarily on the flow of data in system and may not capture other important aspects of the system such as user interface design, system security, other system performance. Require technical expertise. While DFDs are easy to understand, creating them require a certain level of technical expertise and familiarity with the system being analyzed. Now I am going to ask one question to all the students. The flow of data of a system or a process is represented by dash. Option A DFD, option B DMD, option C DJD, option D none of these. Pause the video and write the answer. The correct answer is A DFD. The flow of data of a system or a process is represented by DFD, data flow diagram. So this is zero level DFD. In this diagram, two entities are passenger and admin, and process is shown in the railway reservation system. The process can be shown as a whole. So from the passenger, the data of reservation can be moved toward the railway reservation system. The ticket is provided to the passenger. Cancellation facility provided by the railway reservation system. The admin will be uploading and downloading train information giving to the user. Reservations can be made by him. Also, he gives the passenger information. So this is zero level DFD, that is initial DFD. Next is one level DFD. So in this first level DFD, the diagram is expanded. So here passenger is an entity. So is a sub reservation process divided into sub processes, that is inquiry, ticket generation process, report to admin. So here reservation storage can be made in the reservation process. So here ticket reservation process is given, report to admin is one process given. So here up storage and down storage can be shown by using the incoming and outgoing arrow. So here passenger can book the ticket or cancel the ticket, and the process can be done by reservation process. Inquiry system also provides information to the passenger. Ticket generation process will be give the ticket facility. So different tools can be used for to create a DFD. Most tools DFDs are created using the special DFD tool, which are sometimes bundled with the other feature that are related to specific methodology being used. These are many tools available, including both proprietary and open source. It is possible to use cloud-hosted tool to create DFD for Lucid Chart, Visual Paradigm, Small Draw, Concept Draw, Smart Draw, Creately, and Concept Draw. These are the different tools available for drawing DFD. These are the references. Thank you.